Hey, what's up guys, my name is Cherno, and welcome to the 12th Sparky devlog. So it's been quite a while since the last devlog, and I apologize for that, but I've been pretty busy lately, and unfortunately, I was actually, the funny thing is, I was going to start this video, and I was going to be like, I don't really have much to report, that's why there haven't been devlogs, but I looked at the last devlog, and I looked at all the commits on GitHub, and a lot has actually changed. So I don't even know what's going on. But basically, last devlog I talked a little bit about planning and just essentially bringing up like the future of what I was going to work on over the next month or so. And then I put out a video on how to contribute to Sparky, and since then actually I haven't actually realized this, but I literally have not put up a Sparky related video since I put out the how to contribute video, and a lot of people have contributed since then. So a lot of stuff has actually happened, surprisingly. So I'm gonna kind of walk through the changes, I guess, and just demonstrate them to you guys, and then talk about what I need you guys to do and what I'm going to do over the next week or so. So let's start off with looking at the Sparky repository. We had, I think, 75 commits was what it said in the last video, and there are 102 now, so clearly a lot has changed. But if we go to the commits and we go down to, I think, okay, let's just, the way I'm going to do this is I'm literally just going to look at, I'm just going to look at the date of the, April 6th was when the other one came out. So it looks like around April 6th, I think. I don't know if I showed you guys the sponsor scene. I've actually got this open on my other. Did I? No, doesn't look like it. I'm just scrolling through my previous devlog. Okay, so yeah, so I guess, I'll kind of, you can kind of see who's been contributing to Sparky just by reading the commits here. But Clr, I don't know how to pronounce that. Added basically this like another test here called sponsor test, which is basically the sponsor kind of test scene. It's like a pretty famous, and now I'm gonna render both of them. It's quite a famous little scene that that is pretty popular in terms of and I need to fix up some. This is going to be real professional. I need to fix up some compilation errors. Okay. The sponsor scene is a pretty kind of popular graphics test that's been around for quite a while. So if we take a look at what that looks like, it's essentially like a full kind of 3D scene. So we can probably see here that if I switch to the FPS camera, this is kind of what it looks like. It's like, yeah, again, it's like a full 3D scene. I actually added FPS camera speed controls to the debug menu just so that we can easily kind of scale it up. But yeah, you can see that we've got the sponsor scene. This is running in Directx 11 here. Yeah, and everything's like, you can control everything as usual with that, the light direction, all that stuff. There are no shadows or anything right now, and no ambient occlusion or other kind of light things, so it looks a little bit dull, but it is technically PBR. It's a little bit hard to tell, but I guess you can probably tell by the I'm assuming if you were to switch out the environment map, it would look quite different. It's just that I haven't actually bothered to create more than one environment, as in like commit or like, yeah, create like more than one cube map essentially for this. But anyway, that's what we have here. It's pretty cool. That's the sponsor scene. So thanks for adding that. Let's see. I did a bunch of stuff. Dynamic shadow reloading is now in Directx. This was what this was a demo for the how to contribute to Sparky thing. The biggest thing, I think one of the biggest things that's changed was the virtual file system. So I added a virtual file system. You can probably see the beginnings of it here, where basically the way that works is that we mount certain directories, such as, like, for example, the models like virtual kind of mount point is set to be this directory, which is res/models. So you can see we have a directory in our sandbox called res and then models. And what that means is that in like test 3D or something, when we load models, what we do is we actually we have a leading /, then the name of that virtual directory, and then again the actual like file name or any other kind of folder hierarchy. And what that means is that this /models directory is a virtual directory, meaning that you can map it to anything, right? Like for example, if I was to change this to be something like, you know, C dev, you know, assets models or something, right? And I could just use forward slashes. If I did something like this, then that would totally work, right? Even like that, it would mean that we wouldn't have to switch this out at all, right? It's still /models as far as all as far as the client is concerned, as far as the game is concerned. The /models is exactly what it is. However, you can see that we've mapped it to something else, and you can also map multiple. Or map like one mount point to multiple directories, and it'll actually keep looking for the files until it finds one that has the file you're looking for. So there's a few cool things you can do with that. If you guys want to check out the code behind that, of course, you're welcome to. It's pretty straightforward. I don't think it's too crazy or anything. But that's kind of there now, and that works. In the future, I would like to extend this so that we can do things like basically looking into binary files, so essentially like a binary blob. So what that is essentially like it would give us the possibility to have a bunch of files or a bunch of assets kind of squished into one large binary file, and then we could use this virtual file system so that the game side looks like it's just loading files. However, they're actually located in one kind of big file, right? So it's like we're simulating a virtual file system inside of one file. And that's something that's pretty commonly done as well. And we can just memory map that file, and then we can kind of do a bunch of things to it. And it also means that we don't have to distribute assets as like separate files. And there's a few benefits to that. So yeah, that's kind of there are a lot of cool things we could do with this virtual file system. But just being able to like map directories like this is just the beginning of that. All right, cool. Yes. Now, this was quite funny, actually. The reason normal maps weren't working in, well, for some reason the reason normal maps weren't working in Directx was because for some reason we were sampling the 8th MIP of it, which is just ridiculous. I don't know why I wrote this code at all. I tried to trace it back and I actually just couldn't. So when I wrote the PBR shader, when I ported the PBR shader to HLSL, I, for some reason, just decided to sample the 8th MIP. So that was why it was all like essentially blurry, and it appeared that it wasn't working at all. So very weird that was there, but anyway, fixed that. Brotherhood of Ham, huge thanks to that guy, because we now support dynamic map generation for 2D textures in Directx, which is something that I spent quite a bit of time on and couldn't figure out. So it turns out that you do actually have to basically specify every single MIP here as like a separate kind of MIP level thing. And yeah, it's all over the place. It's a bit annoying, but it is what it is. And luckily that's in there now. As you can see, we have to like fully like, yeah, we have to do a bunch of stuff. Well, I mean, we don't generate every single one or anything. It's just that this is just us working out which MIP level we want. And then, what else is going on here? It's been a while since I read this code because it's like a month old almost. Actually, it's more than a month old. There you go. But yeah, basically we have dynamic MIP map generation here, and yeah, we even like check support for that and stuff like that. So anyway, all good. This is now working correctly, which is why you saw in that sponsor scene that it looked quite nice. Yes, now from the VFS branch, I believe I also merged in Win32 platform specific stuff. So before we used to use, if you guys remember file utils, which I haven't deleted yet, that was how we kind of loaded strings. We had no way to load binary files, like as in the way that we loaded binary files was literally just by using like file. So it was like, it wasn't even through the API or anything. In fact, we still can't do that for some reason. Actually, that should definitely be replaced. Oh, I guess it's because we're reading it kind of byte by byte and stuff like that. But anyway, this is how we used to load like files as strings and all of that stuff, text files. However, now what we've done, because we get a lot more control over it, is there's this file system and I of course did this while I was creating the virtual file system. There's this file system that we can use here, which basically is like this is a platform independent API. But what happens is it has platform-specific implementations. So for example, we have Win32 file system, and you can see this actually uses Windows, and it actually properly uses the Windows API to read stuff. Now, you might be asking, why on earth would I write a platform-dependent file system, or like a platform? Why wouldn't I just use like a platform-independent kind of portable file API that like C or C++ provides? The reason is, well, there are two reasons. First of all, the big one is that it just gives me a lot more control, right? For example, if I want to list the files in a certain directory, if I want to see how big a file is, well, how big a file is portable, but like, for example, listing files, all files that are located in a single directory and all that stuff is platform dependent, right? You have to write platform dependent code for that, unless you use like some third-party library that I guess does it for you. So we have to do this stuff anyway. But also there is the potential for optimization because we can control everything, right? And also you have to realize that file and IF stream or whatever under the hood calls this code anyway, right? When you fopen something, and I love saying fopen, when you fopen something, it calls create file, right? That's how it works anyway. So it's not like we're doing this differently. It's just that, yeah, we kind of get more we get finer control over how this works exactly. And it shouldn't be too difficult to port to other platforms when we do that. Like this took me like an hour or two potentially to write. Like it was really easy. And it wasn't something that was too difficult, and again, it is worth it. So anyway, that's how that works. And obviously for like stuff like text files, like it's good to do stuff like this because, yeah, again, we can, and this isn't like fully optimal yet, but in general, it just gives us finer control. And you have to remember that it ends up kind of like the cross-platform stuff ends up calling this anyway. Okay, cool. I'm gonna speed this up because of reasons. Okay, the other big thing was font metrics, right? Because the video was getting too long was the reason, by the way. Yeah, we had like, this is just some fixes for files not, like handles not being closed and stuff. Yeah, font metrics was good. So we can now see how big, like basically if we look at, this was me fixing the ridiculous color. There were problems with with the 2D rendering API. But basically what I added was this stuff, which was the ability to get the offsets. Like there's a bunch of things here, but for example, getting the width of a string using like from a font, the height of a string as well, and the overall bounds of a string, which is very important because what that means is we can measure how big strings will be when they get rendered. And that's important because of, for example, a good example of that would be like the debug menu, right? So when you activate the debug menu, it measures, it creates the debug menu items, and then what it does is it essentially measures the bounds of that item's label, right? And by doing that, by measuring the width of the string, it knows how big it needs to create, like that background, so that when we launch this, come on. So that when we launch this and we open up the debug menu, you can see that it basically makes this like these rectangles in the background here exactly the right size so that they fit like the text, right? Because if you notice before that went in, the only way for us to actually like we were just setting a static height and that was it, and we had like a bunch of text bleeding over the edge and stuff. Like if I put in like a really long debug menu item, such as let's just say test 3D, where do we add ones? So like let's just say I make another one, but this one's like really long, so we have Dagagloss written twice or something, and then you'll see that the actual like the width of that debug menu becomes larger, and that's all because we can measure the string. What? I'm silly. Let's add that. Actually, let's just launch test 3D. Because it loads quicker. Where's Sandbox? Sandbox. All right. Test 3D. Here we go. It still takes a while to load. Okay, so that's not even that long. This is a great demo. You can see that I really prepared for this stuff. So I do that all the time. Professional Cherno. All right, so this is definitely a long string. Dagger gloss, dagger gloss, dagger gloss, dagger gloss. All right, come on. I wish I was running this in release mode. All right, so you can see now that the debug menu is very wide, right? So we kind of get that positioning, and of course they're bound to the same value, which is why they're both changing. But we get that that width and stuff thanks to and of course, by the way, the performance for this debug menu is something's very wrong with with something that I'm doing. But anyway, yeah, you can see the width is dependent on the font metrics, which is good. So that's font metrics, so we can measure stuff now, which is great. Measure strings. Yeah, Directx now prints GPU info, like the same way that OpenGL did. We can print wide chars, I believe. That was important for something. I don't know why. But I guess I just wanted to print that for some reason. Oh yeah, because some of the stuff that we get from Windows API is like wide char only. By the way, like I realized that in terms of strings, like I'm really only like Sparky at the moment only supports 1 byte chars. Like we don't have like UTF-16 or 32 support, or well, UTF-8 kind of, I guess. But UTF like 16 and 32 we don't support at all, which is obviously not great. We want to be able to support those because of like let's just say languages other than English, but also fonts with symbols that we may want to use. So not great that we only support ASCII, but yeah, supporting UTF and stuff like that would be great, but that's, yeah, later. Vsync support to Sparky, so we can toggle Vsync. I don't remember how I did that. Oh yeah, well in Directx it's just presenting that thing. So this is great for like full screen rendering. If you're rendering in full screen, you will notice that if you do have Vsync turned on, there will be no tearing, whereas before, even if it was technically saying that it was running at 60, it was fake, like limiting it to 60. So there was like a lot of screen tearing going on. So that can now be fixed by simply enabling Vsync. I also added, I don't know where I did this, but so debug layer stats are now properly, oh yeah. And because of font metrics, the other thing you'll notice, man, this is going on for a while. I was gonna, 17 minutes, oh my goodness. All right, sorry. I hate making long videos because now I have to wait for this to render and upload. And with Australia's internet, this is going to take a while to upload. You can see that these are like these stats that we have here in the debug layer are perfectly right aligned. And you can see when the FPS increases like above 10, like for example when I open the debug menu, anyway, ridiculous. You can see that like it doesn't move at all. Like it doesn't, before of course it would make the string wider and thus it would kind of offset this, but you can see that it actually kind of, it's right aligned. And that's because that's another thing that we're able to do because of font metrics, because we know how wide the strings are, which is great. Build configuration and platform now available via runtime. I'm just going to launch test2d because I'm really getting sick of waiting for test3d to load. This just should be like instant. So basically the idea is that if you run, oh yeah, this error, I need to fix that. Anyway. Oh, yeah. This has to do with some Visual Studio 2015 stuff. What's the... I guess this is the smallest one. Okay. Oh, lols. Okay, so we have... by the way, these were the DirectX stats that we print. Like, for example, the VRAM, as you can see there, and the graphics card. Okay, so you can see that the title has Sandbox Debug Win32 written in it. So the Debug Win32 is the part that I added. Like if we were to switch this to release mode, this is a terrible idea because, oh, maybe not. No, yeah, it is. It's terrible. Anyway, that'll take a while to compile. While it's compiling, it'll say release Win32. That's kind of the point. And that's easily achieved. Like the way that I've done that, by the way, is just by, let's see. So we have get build configuration and get platform, and essentially the platform, well, in Win32 application.cpp, that will always return either Win32 or Win64 based on certain if stuff. And then I think application.cpp must do the other one. Yeah. So this get build configuration just basically looks at the macros yeah, just sets the appropriate one. So you can see it will be now set to release when it finishes compiling. What else? Fixed solution build configurations. Don't really know what the issue with that is, or what I did. Okay, I removed. Okay, one of the things I did was first of all remove 32-bit from from SPM build, since that requires 64-bit clang, or at least that's the way I've done it. So it has to be 64, because otherwise, like, people were getting compile errors because they were trying to build it in Win32 and you can't. So just to fix that up, I made it unbuildable. And also I think I removed some other stuff. I don't remember. Okay, so anyway, see how it says release Win32? Yeah, all right. So, and then I added continuous integration. That was a big change. So basically, every time, okay, that's good for two reasons. First of all, you can see that it verifies the master branch. So we actually try and build the master branch. For those of you who don't know what continuous integration is, basically every time the code changes, there's like a server which does a full clean build of the Visual Studio solution, or like, you know, of the project, and essentially you see any errors and all that stuff. And the idea is right now you can see it's building both debug and release configs, and anyone can view this, by the way. This is the log for that. So AppVeyor is like a little, it's like kind of like there's another one called Travis, which is good for like Mac and Linux stuff. However, if you want to, you know, a Windows build, so if you want to build this using MSVC, which is the Visual Studio compiler, then obviously this one's like the only one I've found that's free as well, because you can see this will use MS Build to here it is, to just build the solution, which is fantastic. And then you can see this took like 4 minutes, so it's not particularly slow. And yeah, essentially this was successful, right? So it just verifies that there are no kind of build errors. It'll do like all configurations, debug and release. And then of course the idea is we have continuous integration for all platforms. Right now we only support Windows, so we only have this, but in the future we'll have it for all platforms, which is good because it means that like occasionally something that you change in Visual Studio will compile fine in you know, the Visual Studio compiler in MSVC, but it won't work in Clang or like GCC or something. Not that I don't think we'll support GCC or G++ at all, really. I think Clang is probably the only one. But anyway, it won't compile. It'll be fine in like Visual Studio. It'll be fine in MSVC, but not in Clang. And we get all those kind of errors. It's obviously easier to just kind of commit this and see if it fails, rather than testing it on like all compilers and stuff. Actually, you really should test it on all compilers. I'm just being lazy, and that's how I usually do stuff. I just commit it and see what happens. But anyway, that's naughty. Don't do that. Test it properly. But that's also good for caching errors. Also, you can get it to commit binaries for you. I haven't had the time to set that up, but basically, once it does successfully build something, it'll commit fresh binaries to the bin folder. That way you never have to commit binaries. In fact, you can see I've kind of stopped committing binaries because it's just too hard to maintain. Like, I don't really feel like doing it, and neither does anyone else really. So the cool thing is the build machine, or the continuous integration, once it does build those binaries, it can commit them and push them. So yeah, that's the idea behind continuous integration. So now we support that. There's a little appveyor.yaml kind of file, which just has the kind of what I want to do. I get an email every time something happens. I'm going to turn that off, because the other reason that this is really useful, by the way, is that everyone who commits stuff, everyone who opens a pull request, it actually verifies, as you can see, show all checks. Yeah, here we go. It verifies continuous integration. You can see it actually tries to build that. So basically, I know whether or not your code compiles. So you can see, like, for example, this code does not compile. And if you do open a pull request, well, it's a lot of commits. If you do open a pull request and you see that your continuous integration has failed, you can look at details and you can look at the log and see why it failed, right? One thing I've noticed, and you can see this person's just looks like, and this is like almost identical. This is identical to the Visual Studio output, which is great because it's really easy to read. Speaking of which, where are those errors at? Borosive. Okay, here we go. So like mathfunc is not a class namespace name, blah, blah, blah. Sometimes I wonder how people can get these errors here. Like, I'm assuming you guys compile your code before you commit it. But anyway, the idea is that you can look at your, you can basically see if your thing is working or not. And if it's not, then you can fix it. Obviously, I'm not going to merge stuff that breaks the build. The other thing is, this is also nice because, I was going to say actually, the other thing that people tend to forget is like on this continuous integration, they will like, it'll compile like on debug, like if people add new projects or they like, I don't know, make changes to project configurations, they only test debug, right? The idea is you have to make sure that this compiles in debug and release. We don't care about mscripting. I really should remove that for now, at least. But debug and release Win32 and potentially in the future x64. In fact, soon, because tools are probably only going to be x64. And the runtime will be both x64 and Win32. You need to make sure that the code that you've written and the changes you've made work for all configurations, right? Just debug is obviously not good enough. It needs to work for both. So that's why this is great, because it lets you... it lets me really quickly see, you can see the failures and the passes here, which is fantastic. And I really need to merge some of these. Okay, and then that's it. So we have a status badge now as well. You can see that it says whether or not the build is passing. This is just for the master branch, this build passing thing. So this should always be passing. Master should always be building correctly. There's no excuse really for it not to be. All the other branches don't really care about them. A lot of them are kind of intermediate branches I've been using for work. So like every time I commit, like a lot of that stuff is work in progress. Most of it should compile, but sometimes it might not. So whatever, we don't care about that. Master is the branch that is like our publishing kind of branch. Okay, cool. That is about the end of that. I do want to say that in terms of what we're working on this week, and again, this is a huge devlog. I guess it's been like a month since the last one, so fair enough, I guess. But things that I'm working on. So the CLI generator tool, I do want to do that still, obviously, but I actually want to write a CLI manually first. CLI, of course, being the intermediate kind of link that we have between the C++ and C# code. So it's like a managed kind of binding for Sparky's API so that we can use it in C#. The reason I want to write it manually first is primarily so that I know what to generate. Because I got to a point in the CLI gen stuff, and you can actually look at that CLI generator by just going to the CLI gen branch, and it'll be in tools CLI gen, right? This is the actual, code for that. And there's a bunch of stuff here. But the idea is that, yeah, and you can see that what it does, like it literally just outputs code. Like, this writes code for us so that we don't have to, we'll be able to automatically wrap stuff. So you can see like a bunch of stuff going on here, like hash include, namespace, SP, namespace, CLI, like there's a bunch of, it's pretty cool. It works like it'll generate like empty, it kind of works in a way, like it doesn't support advanced things like, well, there's a bunch of stuff it doesn't support. For example, like inheritance and stuff like that, it's still a bit shady with. But there's a bunch of stuff that it does support, and it will eventually work. I just need to actually write it myself first so that I know what to generate. But basically, I'm going to push this. This is going to be on a branch called CLI, right? So not CLI gen, just CLI. And if you feel like learning how to write C++ CLI code, and you want to contribute to this, because all this is just wrapping code. So you can see that, for example, we have, say, like the constructor for application, and we have like this virtual void init, void start, suspend, resume. And what that translates to, and let me find a good example for you guys, because I'm not finding any good ones. I think Windows all right. Yeah, Windows pretty good. So you can see that like window.h, for example, only the public stuff we care about, public and protected. We obviously don't care about private stuff because we don't need to expose that to C#. Because it's private anyway. We have all these methods that we write here, and then all it does is, you can see, like, it's a wrapper. It just calls stuff. Occasionally you have to do conversions, like for example for strings and like for arrays as well. You'll have to do conversions. So of course set title calls the actual kind of one inside Win32 window, because it'll call the one in window, which takes us like an STD string, and we give it a system string, which is a C# string, and we have like conversions between those things. And anyway, the idea is that this code is kind of easy to write. It doesn't take a genius to write it. There are some certain hard parts, and you can see that I've got like this is like shaders, for example. Yeah, we have this is old code. This is from the old Sparky CLI stuff, but I've started updating it now, and hopefully we can have a complete binding for C# just by like writing all this code. So if you guys want to help out on that, it's not particularly difficult. It'll be great for you guys because you'll learn essentially a new language called C++ CLI. You can always ask me questions on Slack if you need help. This is a great time to promote Slack as well. I've got a Slack team. There's a Sparky channel. I'm active here all the time. You can see me replying to people. Exhibit A. You know, hang out here if you want to contribute, especially. But yeah, just if we could get some people working on this, it'd be fantastic. And of course, you guys will probably learn something new, such as C++ CLI. And we'll get some of this wrapping code done because I really don't have the time to do this, and I'd rather work on kind of harder things. But we do need to get this stuff done. So if you're looking for, if you were like thinking about contributing to Sparky, but afraid that like, oh, I don't know how to do this, this is a great little thing to do because a lot of it's really simple. So if you want to work on it, one of the things that I'm afraid of, and that has been happening to an extent, is people, like multiple people working on the same thing. Obviously this wouldn't happen if we were like in an actual team, you know, physically. But you know, to make sure that you're not working on something that other people are working on, you should just kind of either open an issue here and say, hey, I'm going to work on this. And like, whilst I can't really assign you to it, I can unofficially assign it to you, and just kind of be aware that people, like, for example, this person clearly has been like, this guy is a fantastic example, actually. I forgot about this. This person here, Aritz Hack, is a Ritz hack, I guess, is working on a Linux build for Sparky, right? And I mean, look at this. Like, this is better than some of the stuff that I've written for like work and stuff. Like, this is like, you know, there's a checklist here, like intentions, progress note. Like, this is actually really, really nice. So you can see like, and he's had like a bunch of questions, right, that I've happily answered. Like, and just, you know, opening a dialogue like this is really, really good. And, you know, just being like, hey, I'm going to work on CLI. I'm going to work on, you know, making sure that, for example, everything in graphics is going to be CLI. Does anyone want to take a look at events or like the audio namespace and maybe start wrapping that code? And, you know, like, feel free to collaborate. And yeah, really just help out with this. Because it's something that, like, I know a lot of people were asking me, hey, is there anything specific you want help with? Apart from maybe looking at issues and seeing, like, you know, oh, I can take a look at post-processing effects, even though I've, like, obviously if I'm assigned to it, it means I'm working on it, so I don't want other people working on it. And that's actually kind of almost done. I think there's a post-effects branch. Texture render targets is actually that branch, I believe. Yeah, added post-effects. So there's a bunch of stuff going on that I'm working on as well. That's the other thing, actually. Post effects kind of work. So much stuff. This project is out of control. But basically, I need your help. So if you want to help out with this, CLI is a really good thing to help out with. It'll be on the CLI branch. Just start opening pull requests with stuff that you do. I'll definitely merge them and make some issues, setting your intentions and the fact that you're working on something. And yeah, let's all do this together, and it'll be great. Okay, so that's going to wrap up this devlog because it's huge. Just some final things to leave you guys with. Obviously, if you haven't checked out the repository, do so. And don't forget to star the repository. We're approaching 500 stars soon, which is pretty cool. And the other thing is, if you want to support Sparky and you just can't contribute, or you don't want to contribute, or you want to extra support Sparky, then you can pledge any amount on Patreon. And this just helps me out by allowing me to essentially set more time aside for working on Sparky. So if you want to support Sparky's development and help me out, then this is a great place to do so. All right, guys, thanks for watching. If you enjoyed this devlog, please hit the like button. Went on for quite a while. Hopefully I'll see you next week with another devlog. I think I'll go back to, I took a little bit of a break, but I think I'll go back to weekly devlogs again. And yeah. Thanks for watching. I'll see you next time. Goodbye.